In this video, we're going to look at scientific notation. We use scientific notation to write numbers that are either really, really big or really, really small. We do it to make our lives easier. Sometimes it's just easier to convey numbers in scientific notation, and we'll see this later on. So when we're doing scientific notation, our number has two parts to it. The first part is our decimal. The decimal part, that's our numbers that we really care about. And when we write the decimal part, we always write it as a number that's between 1 and 9. If it's any other number besides that, we can usually move the decimal to make it a number between 1 and 9. Then our second part is the exponential part. Our exponential part is telling us what that power is raised to. Or you can think, how far did we move the decimal point to get to that number that we have here? So our exponent is always n, and that's whatever this number is here. It can be negative or it can be positive. And so when I talk about moving the decimal around, when you look at scientific 10 raised to the 1 power, then it would be 1 times 10, which equals 10. Or if I raise it to the 2 power, that'd be 1 times 10 times 10, which would give me 100. You can see 3 power would be 1 times 10 times 10 times 10, gives you 1,000. We can keep going with this, 10 to the 4th, 5th, 6th, 10 to the 100th if we want. And the same thing can happen with a negative exponent. When we have a negative n, that just means we're dividing by 10 times. So if I have a negative 1, that really means I have 1 divided by 10, or 1/10. If I have a negative 2, that'd be 1 divided by 10 times 10. Or you can also think of it as 1 divided by 100, which would give me 1/100th. Negative 3, that'd be 1 divided by 10 times 10 times 10. Or you can also think about it as 1 divided by 1,000. You can kind of see how it's going here. When it's negative, we're dividing. When it's positive, we multiply it. Really not too bad, right? And so then when we're looking at moving a decimal place over to try and write something in a scientific notation, let's say we had 5,983. If I want to write 5,983 in scientific notation, I would take that decimal point and I'd move it over 1, 2, 3 times. When we move it over 3 times, that 3 becomes our exponent. So that tells us how many times we shifted that decimal point. And when it's positive, the decimal point gets moved to the left. When it's negative, the decimal point gets moved to the right. So in this case, we go 1, 2, 3, 4. So that's where you get your negative 4. You get 3.4 times 10 to the negative 4th. So it's really not so bad. It's an easier way to write our number sometimes. This way, if we had something that was really small, we wouldn't have to write a bunch of zeros in front of it. So if you had something to the negative 8th, you wouldn't have to write 0.0000007 times to the 8th, whatever it is to the 8th. Makes our lives easier that way. Trust me, you'll get used to it. So now let's do a little bit of practice. If we have what we call our normal notation, this is kind of how you're used to seeing numbers and writing about numbers. So if I have 3,245, which way would I move the decimal point? Well, we'd move the decimal point to the left. If we move it to the left, we get 3.245 times 10 to the 3rd, because we'd have to go 1, 2, 3. So now let's look at our next number. Now we have that same 3,245, but now it's really small. So since it's a much smaller number, and it's a number smaller than 1, we're going to move the decimal point to the right. And to find out how many times, you go 1, 2, 3, 4, 5, 6. So you have 3.245 times 10 to the negative 6. And yes, even I have to kind of count sometimes. Sometimes it's too hard to just see with your eye. You have to kind of count them. So now looking at our next number, we still have that 324, 3245, you can see I kind of liked it when I made this. But now it's a much greater number. It's a really big number. So we're still going to move it to the left. But now we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Having the commas kind of helps make it a lot easier so you don't necessarily have to count like this. So we have 3.245 times 10 to the 9th. So now you can see with scientific notation, having to the 3rd versus to the 9th makes a big difference. Even though these 4 numbers are the exact same for all of these, the scientific notation here tells me I have very different numbers. And so now if we look at the next ones, we have a number that's smaller than 1. So our decimal point is going to get moved to the right. And it's going to be 5.0607 times 10 to the negative 3rd. Now, even with something as simple as 88, we can write that in scientific notation. We can pretty much take any number we want and write in scientific notation. So since 88 is greater than 1, we're still going to move it to the left. And you end up with 8.8 times 10 to the 1. Not necessarily easier to write that way, but it's still good practice for us. And then our last one is 2.45. So 2.45, it's already a number between 1 and 9. There's no way to move that decimal point. So we actually don't have to move the decimal point. You can still write as 2.45 times 10 to the 0. This means we're actually not moving the decimal point at all. That's why we get to write 0. So now you guys should be able to start writing our numbers in scientific notation whenever you need to.